ocean is the cradle of all life on our planet. Humans have known the health benefits of the sea for centuries. Today, scientists are digging deeper, finding cures for some of the most stubborn diseases in the ocean itself. In the Algarve, famous for its stunning coastline, a Portuguese biotech company, Sea for Us, is working on a non-opioid analgesic, a safe and effective remedy for chronic pain.
The need is enormous. I mean, it's 1 out of 5 of us has suffer for some kind of chronic pain. It's my dream now is to find something that can help them coming from there.
Co-founded in 2013 by Portuguese neurophysiologist and marine biologist Pedro Lima, Sea for Us works on EU-supported projects, collecting and studying simple marine organisms like sponges and other invertebrates. Scientists spend their time between laboratories and the depths of the sea, making regular dives for new samples.
What makes you think that marine invertebrates would contain the molecules that you're looking for?
Many marine invertebrates are stuck in the rock, they can't move. So they develop this venom that has these compounds that block the signal, the neuroactive signal related to pain.
Simple marine organisms can be used for a wide variety of purposes, not just healthcare and pharmaceuticals. Blue biotechnology is a fast-growing sector. In Europe, this market is estimated to grow to around 10 billion euros by the end of the decade. It's a whole world of unexplored potential just waiting to be discovered. At a depth of around 20 meters, a variety of marine fauna covers the rocky cliffs. Scientists look for patterns that indicate defensive venoms that sponges produce to protect themselves from their neighbors.
Who eats what? What is avoided by who? What's the next neighbor? All that is the relationship between species, which give us clues what to choose.
We dive inside a very dark cave.
There's less light, so competition becomes more specific. Sponges don't need to compete against fast-growing species like algae. They fight between each other, and we are interested in that fight. Funny enough, I'm actually claustrophobic, so if I'm stuck in the elevator, I'm in trouble. But under the water, no problem. I'm in trouble when I'm away from the water too long. That's the problem.
An unexpected catch. Someone's lost rope. A source of plastic pollution and possible evidence of illegal fishing in this protected area.
It's quite often actually around the places where we go for a dive. It's octopus traps, fishing nets, plastic bags, metal cans. As long as we care about the ocean and try to avoid dumping plastics or other litter, we can receive something back from the ocean, from the nature, to use for our health.
Scientists collect the bare minimum as samples to make sure they preserve populations here.
The impact is close to zero. We take very small samples. The idea here is to be inspired by nature, and then we can recreate it, upscale it to industrial scale. So we don't need to go back to the sea to count on the biomass. The biomass is just inspiration.
In Lisbon, the collected samples are studied by the Sea for Us Physiology Laboratory at Nova University. The process can take several months or even up to a few years of work. Sponges and their symbiotic organisms produce hundreds of individual compounds. Scientists test them for anti-pain bioactivity, gradually narrowing down their search.
It's a whole system. It has bacteria, it has a microbiome of its own. So we just extract, test. If it's okay, we keep on separating, and we separate as much as we can until we end up with one compound that's responsible for the activity.
Sea for Us say they have found 2 molecules that reduce pain activity in spinal ganglion neurons. They plan to provide them to the pharmaceutical industry for the next stage, medicine development.
Our results have showed that our compounds reduce the level of pain. The risk of developing addiction is also mitigated. By combining these two results, we think that our compound will pass through all the clinical studies until reach the market.
The ocean might hold cures for some of the worst threats to public health, from viral outbreaks to antibiotic resistance and cancers. Marine research and healthy oceans are some of the priorities of Horizon Europe, an EU programme that funds scientific projects in all the member states. Here in Porto, researchers from the CIMAR Centre study a variety of marine life forms, big and small.
We are collecting cyanobacteria. They are very ancient organisms and they can grow basically everywhere. They produce these molecules, these chemicals that may have really interesting applications in the future.
Cyanobacteria are known for their potent toxicity, but for scientists, this can be the flip side of medicinal properties.
In principle, any disease could be cured as long as we find a molecule that can treat it. And that's why we look into cyanobacteria, because they produce such a high variety of compounds that it is possible that we can find an interesting molecule to develop into a medicine.
CIMAR scientists take samples from various countries, isolating and cultivating new species of cyanobacteria. Their library of over 1,000 strains is open to researchers from Europe and from around the world. Studies show that some of the toxic compounds can precisely target cancer cells, which may pave the way for new therapies. Experiments on fish larvae show encouraging results that could help in the fight against diabetes and obesity.
It's still a long way to solve the problems of cancer and obesity, but we are on the first line of research to find a solution that can be developed to tackle these diseases.
Marine biotechnologies could be a sea change for humanity, but only if we find a way to use its healing potentials without damaging the sea itself.
We have to learn from nature. We don't have to invent new molecules. We just have to look for those that exist already, that are produced by these organisms, and then eventually slightly transform them in order to serve our needs. And so I believe that in the near future, we will have many more molecules coming from the ocean that will solve many of our current diseases. Life starts in the ocean, and I believe that our life can be saved by the ocean as well.